G'day everyone, today we are having a look at how to do some color matching of imagery in QGIS. I'm going to give a quick demonstration of how to use the script in this video, and then I'm going to be going through how exactly the script works. So the scenario is that you have some imagery like what we're seeing here, and you decide that it is not coloured, it's not kind of tinted the way that you're after, and you want it to have a bit of a different look to it. And so let's say you then have some target imagery, right? So you've got an image which has the desired sort of look that you're after. You know, you're looking at the colour of the grass and the trees and all that, and you're like, okay, that's the sort of look that I want, as opposed to what this initial image looks like, which is a little bit too blue and, yeah, not looking ideal. So obviously if you do go into the properties for this layer, you have the option of adjusting things like the hue, as well as playing around with contrast and saturations and things like that, which is good. You can do some light corrections using that, but if you want to have some more advanced correction than just using hue adjustments in the properties of the image, then that's where this script comes in handy. So once you grab the script from the GitHub that I've linked in the description of this video, and you put it into the Python console here, what it's going to ask you to do is supply three things, which is the path to the initial image, the image that is tinted that you're wanting to correct, as well as the path to the target image that has the look that you're after, and then also the amount of correction to apply. Now what I find is that if you have this up at like 0.789, then sometimes it can be a little bit extreme and it can kind of go overboard in the correction that it applies. But just for the little testing today, we're going to leave this at 0.5, and so in theory, as long as everything works perfectly within script, once you've entered that in, you just need to hit go. And okay, hang on a second. Okay, so you will need the sklearn module in order to make this work, and if you're struggling to install it, I found out that the way to do so is by going into command prompt and changing the directory to where the Python scripts are installed within your QGIS install, and from there you can go pip3 install scikit-learn, and that'll install the sklearn module. Anyway, so once that's done, hit run, and it will tick away. Let's see how long this takes. Okay, so that was relatively quick once it's working, because it's fairly small imagery that we're working with here. So if we have a look at the result here, and so if you compare the original with the corrected version, you can see we're getting a little bit closer to the target that we're wanting. So that definitely looks a little bit nicer, and so have a play around with the script, have a play around with different correction amounts to see what works for you. And that's basically it in terms of the demonstration. So now what I wanted to do was go through all of the details of how the script actually works, and hopefully this might help out if you're running into any issues or errors with the script at all. So as mentioned, you need to make sure that the sklearn module is installed and is accessible by the Python that's used here in QGIS. So with the compress options, so ZSTD was picked here just because it's a little bit faster. It shouldn't matter too much. What did seem to matter was that here under GDAL options, I previously had overwrite here and use all CPUs here, but it was causing some crashing, which I didn't really quite understand. So for the moment, I've just got this variable blank. Yeah, it does seem to depend which version of QGIS you're using, but at least on this new fresh install of QGIS that I've got going, this GDAL options is best to be left blank so that it doesn't crash it. So further down in the script, there's some fairly basic things at the start to create the directory where all of the processing happens, as well as getting the pixel size of the initial image as well as the target image, which is important for making sure, well, it's important for getting a resampled version of those rasters, which we'll see fairly soon. So what I've done here is I've defined a series of tasks here and then run them further down, so that way there's a little bit of multi-processing going on. So we've got 1, 2, 3, 4 tasks here, and then we've got 1, 2, 3, 4, that's them being run, so that way they're run in parallel. And so what's run in the first task is, as you can see, we're resampling down to the we're resampling to a larger pixel size, so that way when we're comparing the two images in terms of the pixel values, we're comparing apples to apples and making sure that any sort of issues with graininess and georeferencing being off, or shadows being on one side or the other of a tree or something like that, just making sure that that's not causing an issue. And at the same time also determining what the relative amount of each of the colors are in the initial image. So as you can see that here, for example, with the red is red minus the green and the blue halved, to see what the relative amount of red is. A little bit further down here, then we are bringing the relative red, green, blue together into a virtual raster and then rendering that out so it's all together. I was having some issues before here with this variable. For some reason in my previous version here I had, I think it was \quote, or was it quote / here, and then I had to take it out in this new version of QGIS. So not too sure what the go was there, but at least this here is working for the moment. So then further down we are getting out the extent of the images in order to determine whereabouts these images intersect, to then create, as we can see, random points and polygons. Random points so we can sample the image in many different places, and that's what happens here, raster sampling to sample what the pixel values are in lots and lots of different places. And then this is where the sklearn comes into play. So this here is a multiple regression. So what it's doing is it's getting in the target image the red, green and blue values, and then in the initial image it's getting the red, green and blue as well as the relative amount of red, green and blue from the initial image. And then it's doing a bit of residual calculation, then multiple regression. I won't go into too much detail about this multiple regression stuff. You'd have to do like a statistics unit, which I did a while ago, and I've probably forgotten most of it by now. But multiple regression, it's basically trying to predict what the target red value is. Yeah, that's right. The target red, green and blue value based on the initial red and the initial green and the initial blue, etc. So those are the predictors. And so once it's done that and it's fitting its residual, then it gets out these coefficients. And further down, these coefficients start to come into play. So this is where we're using that multiple regression, which determines how to predict the target image, and we're applying it in a GDAL raster calculator. So we've got, for example, A here is red, and so we've got red, just regular red, with this coefficient, and then we've got red squared with this coefficient, and then we've got red cubed with this coefficient, etc., etc. So we've got the entire multiple regression here applied onto onto the red band of the initial image, red and the initial image and the relative image, and the output of that is this calced raster here. And so that applies to both green and blue, and so that's obviously with the multiple regression applied. But then what I found is that the pixel values ended up not being nicely between 0 and 255. So what I determined was what we see here is putting these random points in the polygons again to sample the raster values and find out, okay, what's the 99.9th percentile for red and 0.1th percentile for red as well, or all these values, to figure out, okay, how can we stretch the values, the pixel values of the calculated rasters out to between 0 and 255 nicely, and that's what these raster calculations do, stretches it out. And then finally there should be, grabbing the alpha band, and then we're putting the alpha band plus these scaled versions all together into a virtual raster with bands 1, 2, 3, that's red, green, blue, plus the alpha band, and then exporting that out as a final TIFF. So basically, once the correction is applied in the multiple regression, as we saw earlier, then you've got the scaled version which has it nicely between 0 and 255, and then that gets exported out. And then finally we've got some code in here to bring it in, just to visualize it, automatically visualize it, as you can see behind us there. So that's basically how that script works. Hopefully that explains things relatively well. I just noticed that there are some backslashes here in this thing, and yet it still somehow worked. I don't know, just for some reason when you're going between different versions of GDAL, sometimes the parameters you pass in work and sometimes they don't, but either way, that's that. Let me know how you go with the script, if it works or not. If you have any issues, please leave a comment, because I just recently jumped onto this fresh install of QGIS and it did not work straight away. So if that's also the case for you, then please leave a comment on what issues you're having, and if you have any other thoughts on what's going on, please leave a comment. Other than that, good luck, and I'll talk to you next time.